Now we know we don't live in just simple linear factor world, right? So we're still talking about linear factors, but this is repeated linear factors. So if you factor the denominator and you end up with something like x minus r squared, all right, the process to do this is break it up. So you have a over x minus r and b over x minus r squared. So you break it up, but you just keep adding on to that exponent. That is just the process. So when you go through and you work these out, just know that is the process that you follow to pull this off. Such as if I have something like to the fifth, just so we have an example, this would be x minus r. This would be x minus r squared, c over x minus r cubed, d over x minus r to the fourth, and e over x minus r to the fifth. Now, I'm not going to give you something to the fifth, but I just want you to see that process, okay? So just squared is mostly what you're going to see. However, it's good to know this is the process. All right, let's do an example. So here I have example 3, and we are integrating 5x squared minus 3x plus 2 over x cubed minus 2x squared dx. The denominator is bigger. It's not something that looks like I could do a u sub with because my coefficients don't line up, right? Okay, so let's do this thing. We're factoring out that denominator. I factor out an x squared, and I'm left with x minus 2. Now, repeated linear factor is this x squared. If there was adding or subtracting anything next to it, that wouldn't be a repeated linear factor. But this one is repeated linear factor because it is squared. And it's just x, which is simple. 5x squared minus 3x plus 2 over x squared times x minus 2. Now here's our process. A goes over x. And b goes over x squared because you have to account for each one of those, right? Then you just do c over x minus 2. That's just a regular linear factor that we work with. Now you get your common denominator, which is still x squared and x minus 2. You don't have to put that extra x in there for an x cubed. Just go with your basic common denominator, and you can always pull that from over here. Now I have 5x squared minus 3x plus 2, because remember, this also goes to this term on the left. That whole thing cancels out. Okay. If you put an x cubed over here, you would have to multiply this by an x. Don't do that. Don't do that, right? Then you're messing with the problem. So here I have one of these x's, let me write it down. One of these x's cancels out. I'm left with another x. Both of these cancel out. I'm just left with x minus 2. And then there I have my x squared. Do you see that? You cannot do the shortcut method if you have repeated linear factors. That's why I'm saying I don't use it that often, just because I don't know. It only has a short scope that you can be used with. All right, I'm going to go ahead and distribute this ax just to move this process along a little bit faster. So you've got ax squared minus 2ax plus a bx minus 2b plus this cx squared. Now combine up. 5x squared minus 3x plus 2. You've got a and c, that are your coefficients there. You've got your x here, so negative 2a plus b is the coefficient of x. And then lastly, you've got your negative 2b as your number. All right. So a plus c is equal to 5 because that's the coefficient of the squared. Negative 2a plus b is equal to a negative 3. And negative 2b is equal to 2. So that's amazing, right? We love it when we have that single one. Now, make your life easy. If you plug this b into this second equation, you know a. So negative 2a minus 1 is equal to a negative 3. Negative 2a is equal to a negative 2, and a is 1. Once you now know a, plug that in to get your c. 1 plus c is equal to 5. C is equal to 4. I didn't have to do a single system. Woo! Enjoy those, right? Enjoy those nice easy ones when you can get them. Now let's integrate. I'm going to integrate 1 over x because that's a, right? A goes in, b goes in, c goes in. Minus 1 over x squared plus 4 over x minus 2. Now, this is not natural log. You get such in the natural log mode, right? Natural log everything, natural log everything. No, it's not. Natural log is 1 over x. This is x squared. So this is the same thing if I were to bring this over here, and I am integrating x to the negative 2. Do you see that? Okay. So now if I were to integrate this x to the negative 2, I add 1 to that. This is negative x to the negative 1, which is equivalent to negative 1 over x. Okay, that's one that we just do in our heads as we go forward, but because it's been a while since we've seen this and we're so into natural log with this so much, I just wanted to point that one out. So here's a natural log of x. Notice this is a negative. With this negative makes that positive. 1 over x. 4 natural logs here of x minus 2. Again, I'm okay with this. Or that 1 over x stays out front. That's not part of my natural log. But you can put these two together because they're added. And you can say plus the natural log of x times x minus 2 to the 4th plus c. I don't care, you guys. Legit, don't, it doesn't, whatever. Right? However you want to do that. Okay. All right. Very good.